Let's look at some higher dimensional arrays. We have array 3D here. You can tell by the name probably what this is, but we can also get a hint by looking at this bracket structure here. You see the three brackets that begin and end this is an indication of how many arrays we have. Let's look along this n-dimensional array and see if we can find two brackets. Yeah, here's two brackets. And here's the start of another two brackets and the end of another two brackets, and the start of another two brackets and the end of another two brackets. So this looks like a parent three-dimensional array inside which there are child two-dimensional arrays inside which there are three columns. So this is probably a 3 by 2 by 3 matrix. Let's look at this. And indeed there are three parent rows, and inside each parent row there are two child rows, and inside each child row are three columns. Let's output the shape. It's a 3 by 2 by 3. So we can explore into this array by using three indexes. And can you predict which number we're going to get? Well, the first is a 1, and this is index 1 of the main parent array. And then there's another 1, which would be probably this second one. And there's another 1 here, which would probably be 44. Let's check and see if we're correct. Yes, it's 44. So what do you figure is going to happen if we drop this third array? Well, we're going to get this row right here, aren't we? The entire row. So let's see if that's accurate. Okay, can you predict what's going to happen if we drop this second index? Well, we're probably going to get this entire 2 by 3 array, right? So every time we drop one of these indices, we get an array of the next lowest dimension. Now, we can assign values into an array like this in the same way that we locate values. What do you think will happen if we assign the value 77 to the entire first index here? Let's see. It turned that entire index to 77, illustrating the concept of broadcasting. And if we go to index 1, 1, and we change this to 34, 35, and 36, then what's going to happen? Well, let's test it out. Well, we changed index 1, 1 to 34, 35, and 36. Now here we're talking about indexing in two steps. And we're going to create a new array made up of the entire index 2. So we should return this entire index. Let's see if that's what happens. And indeed we return that entire index. Now we're going into step 1 to get the 0 index, step 1, which should probably be these 5s. And we're going to assign that to an array, step 2. In step 3, we're going into this array to get the second index value, which is probably this 555. Now we can index with slices just in the same way that we did one-dimensional arrays. But do we still have a two-dimensional array here? Here's the 2D array that we initially created. Let's run that and make sure that it's available. And we'll run it again so that we can see it down here. This is saying to stop at index 2, but remember, index 2 is exclusive. So what do you think we're going to get back? We're going to get back everything except index 2. Now, what do you think happens if we start at index 0 and end at index 2, and then we start at index 0 and end at index 2 again? We're indexing too deep at this time. Let's see what we get. In our first index, we're getting from 0 to 2. Of course, 2 is exclusive, so here's 0 and 1 and 2, but 2 is exclusive, so from our first index we get this. In our second index, which we're decoding here, the same thing. Here's 0, which is inclusive, and we're including index 1 there, and index 2 is exclusive.